Here we have problem number 14. So it states that find the asymptotes and sketch the graph for the following equation: y is equal to 1 divided by x minus 1. So here I have my y-axis, my x-axis, and so really what we're looking at is those characteristics, again, because we're looking at we're looking at a rational function, right? So we want to look at the asymptotes, the x-intercepts, the y-intercepts. That's an important part of pre-calc. So let's just look at the horizontal asymptote. So if you recall, a horizontal asymptote, right, we are looking at the coefficients, the degrees, right? So we know here that the degree of the numerator is obviously less than the degree in the denominator. Therefore, the rule states that if that is true, then your horizontal asymptote is y is equal to 0, right? Unless if your degree was greater, obviously you would be dividing, and then there would be a slant asymptote. If your degree is the same, then you're just doing a over b, the division between your coefficients. So for this one, however, we know that our horizontal asymptote is y is equal to 0 because the degree in the numerator is less than the degree in the denominator. So that's our horizontal asymptote. For a vertical asymptote, we know that x is equal to 1. It's pretty obvious here because at x is equal to 1, the denominator value is 0, and therefore the entire expression is undefined. And then our x-intercept is a value of x when y is set to 0. It's obviously none here, right? And it makes sense. It's not going to cross the x-axis here because we have a horizontal asymptote there. If you want to check your work, obviously, you know this is the value of x when y is set to 0. We set this to 0. X minus 1 times 0 is 0. And 0 obviously does not equal 1. So for our x-intercept, we don't have any. For our y-intercept, that's just the value of y when x is set to 0. So that is just 0 comma negative 1. So we have our characteristics here. We obviously know that there's no hole here. We have the vertical asymptote at x is equal to 1 because this is a distinct factor. But there are no factors that are common, so there are no holes here. So we can now plot this here. So we have our vertical asymptote here at x is equal to 1, right? And then we have so this is just the x-axis, right? Y is equal to 0. So that's where our second asymptote is. And then we know that we have our y-intercept at 0 comma negative 1. That's here. And then, so that's all we know. But if we know that there's a point here, and with experience and practice, you'll probably know that your graph, your curve will look something like this. Obviously, you can plot in more points. And then your second curve, if you plot, for instance, 2, right? So let's just plot 2. We see that's 1 divided by 1, right? So that's equal to 1. So when we plot the point 2 here, right, that gives us 2 comma 1, 2 comma 1. Now if we plot the point 3, right, if we plot the point 3, we get 1 divided by 2, right? So we have a point that's 3 comma 1 half. So you see that this curve is going to be something more like this, right? So here's our graph. We have our x-intercepts, y-intercepts, right, and all the other characteristics. And we may be asked if there's a slant asymptote. So obviously in this case, slant. It's not applicable here in this case. And then, does this graph have symmetry about the x-axis or the y-axis? And for this one, that will be none as well. We clearly see that the curve doesn't reflect about the x-axis or the y-axis, right? We don't see any symmetry about the x-axis or the y-axis. So that's question number 14. Thanks for watching.